Okay, in this lecture, I'm going to go over the final project example. Um, just a brief overview so that way you can know how to navigate everything. So I'm going to go ahead and share my screen. And so you'll see right here, this is the final project example. It is a completed example. There is no reason for you to share your work with anyone else except for the other people in your group. Please do not share your work between groups. I've actually, the only reason why I've ever dropped anyone from this course is because they literally shared their work with somebody else, and that person took that work and turned it in as their own. Didn't make me too happy. I do actually read all of your projects, so just be aware of that. So this right here is the very first tab is the Excel formulas. You'll notice that there are a lot of Excel formulas for doing hypothesis testing. And so this is just a really quick reference for you of the Excel formulas, what distribution they're for, the critical value, or what it gives you, what the Excel formula gives you. The simple explanation of what it is. I don't know why this is the way it is, but basically T dot inverse, I'll fix that in just a minute, but it will give you a simple explanation of exactly what it is that it gives you. The components basically, what it says probability, degrees of freedom, and what it actually is in comparison to like what we chat about in this class. And then what does this function do? And so what this function does, this, if I'm not mistaken, is what Excel tells you it does. And so just be aware this is here for you to be able to use as you go throughout this project, and it can also be a really good, useful tool for you throughout your time in business. So this right here is an assumption testing worksheet. You'll notice there you actually already have this, but you have the actual Excel document. Single sample, independent sample, paired sample, goodness of fit, and goodness of fit unequal proportions. This has the you have the different assumptions. Then you also have what is being examined, the dependent variable, the independent variable, the observations, distribution, outlier, and variance. And so just different information about that. So be aware that all this information is in here over assumption testing. Next, because I know how much you guys love my decision trees, I have a decision tree for you. And when you use this decision tree, you can ask yourself, okay, am I dealing with frequencies of categorical data? Am I dealing with continuous data? And you can go down this decision tree to determine what it is that you're actually supposed to be doing. And then, you might determine, okay, am I going to be running an independent samples test, a paired samples test, or a single samples test? A chi-squared goodness of fit, or a chi-squared goodness of fit for unequal proportions. And so there's actually an example for the chi-squared goodness of fit right here. And then there's an example of how to run through paired samples, independent samples, and actually the math right down here. And then there's also the math for a single sample test right here as well. Then we have the single sample reference, independent sample reference, paired sample reference, goodness of fit equal reference, and goodness of fit unequal reference right down here. And so as you go through the different tests, it gives you the purposes of the test. It gives you the assumptions. Gives you like how to write null and alternative hypothesis for non-directional and directional. And then it also gives you right here the how to calculate the effect size for each one. And so you'll notice to calculate Z-calc and T-calc for a single sample is right there. And coming into independent reference, there's some students that really enjoy the formulas, right? And no problem with that at all. If you want to see how these formulas are put together. I painstakingly actually went through and typed all these in with the appropriate notation, making sure that it was correct. But then we also have all these, the Z statistic, the T statistic, so on and so forth. And then we have the assumptions. We have the hypothesis examples. We have the effect size right down here. And yeah, um, there's more information on effect sizes and whatnot in the actual video on effect sizes. So just be aware that this is here. Paired reference, same thing, T-calc. Then we have coming right down here, we have the effect size. And then we have the determine the purposes of the test, the assumptions, and another reason why you're going to want to know the purposes of the test is in your uh, what's that called? uh, in your final project, I specifically ask you, what is the purpose of running a test? And so you'll notice right here, it says compare a sample of Atlanta salaries to population average to see to average salaries to determine if difference exists. So what you're doing is you're going to single sample reference and you're saying, okay, which of these purposes am I accomplishing? And so you're going to compare a sample to a population to see if a difference exists. And so instead of just doing that, you can copy this and go over to single sample and then do compare a sample of Atlanta. So you're going to want to make it specific to the data set that you're working with, Atlanta salaries, to a population average of salaries to determine if difference exists. Okay, so you see how easy that was. Another thing that I'd really encourage you to do, something that kind of drives me nuts, please use spell check, um, because it's gonna make your life a lot easier. But Excel does not automatically do spell check for you. So just click spell check and make sure as you go through, because what I just did there, I accidentally typed an average wrong. Um, and so yeah, so paired sample and then goodness of fit. There's a nice little example right down here with goodness of fit for equal proportions. And the really cool thing is the example for unequal proportions is the exact same scenario as goodness of fit for equal proportions. Just one is they're all the same. The other one is they're all different. And so please be aware of that. Also, the chi-squared is definitely different. It's a different distribution. And then the effect size is a completely different effect size, so on and so forth. So go through these, and they're a really good reference tool for you to be able to just make sure that you know how to do all these different parts. Then as you go through the single sample, independent sample, paired sample, chi-squared goodness of fit, this is a really good example of how you should complete it. I'm not going to say it's a perfect example, and the reason why is because I have slightly changed things over the years, but I think it's pretty, I think that this is, I think I made this last semester, or updated this last semester rather, and so it should be a really close representation of what you should actually put in there. Um, and then let's see here. This is, we're going to get rid of that. Um, there we go. So we've got the test calculated, and just follow this going down all the way down, and it gives you a really good um, example of how to do everything. And then I give you some examples right here, like for instance, if it's how to interpret skewness, how to interpret kurtosis. The way that you interpret kurtosis, um, I know that I put it in there somewhere, but I really wouldn't worry about kurtosis unless it's more than 3 or less than -3. So I would not worry about kurtosis unless it is beyond +3 plus or -3. Okay. And some people even say ±5. Let's see here. And then you're going to have, this is the null and alternative hypothesis. You're putting the words for the null and alternative hypothesis over here. And so what I'd suggest is that you do almost all of this individually, this part individually, because it's going to really help you to succeed on the exam. And then you guys can come together as a group to complete these individual parts. Also, the effect size, the way to calculate the effect size is over on the right-hand side. So just be aware of that. And then independent samples, once again, here's an example of independent samples. I will be, I think for the most part, I know that there's a few issues in here that I think I may have forgotten to correct. And so just be aware, if something seems really weird, let me know and I'll fix it. I know that there's like two places in here where I really messed up some text. And so I've got to find those places. So as I go through it, I'll update you guys if I find where those places are that are messed up. But there's an example of pretty much how to do everything for every single individual one. Also, if you want to work with the real data, I do have the real data in here if you want to get some more practice with like legitimately combing through data and working with it. I have the real data in here as well. So that's basically the overview of this wonderful Excel worksheet for you. I'd encourage you to really take a look at it and make sure that you thoroughly understand how to use this, because it's a phenomenal asset and just helping you guys to be able to navigate the final project quickly and efficiently.